Okay, so our topic for today is going to be inverse functions. And basically the theme for inverse is, it's loosely, the way you can think about it is it kind of does the opposite or the reverse of what you would normally think of for a function. Now, it's technically not quite the reverse, but that's a good way to think of it. So for example, if we multiply by 10, we have to think about how we undo or reverse that operation. So how would you reverse a multiplication by 10?
Divide by 10.
Yeah, so simple. It's going to be divide by 10 is going to be the inverse there. Subtract 5. Yeah, plus 5. So add 2 will be subtract 2. What about if I have multiple operations, like multiply by 3 and add 5?
Take away 5, divide by 3.
Yeah, so you have to be careful about your order of operations, right? To undo this, first you would do the subtract 5. And then we would do the divide by 3. So I probably should put the subtract 3 in there. So for this, subtract 5 and then divide by 3. Okay, in order to completely undo it and get back to where we started. So let me show you what that looks like with a couple of functions. So for the first one, 2x minus 4, I can make a table of values. So we're just going to compare what happens. For example, when it's at negative 2, that means I'm going to be at, let's see here, it's still early, but I believe it's negative 8. Then it should be negative 6. Then it should be negative 4, negative 2, and 0. If I take a look at the one here, this is the notation you're going to see for an inverse. So I'm claiming this is the inverse, the one that undoes it. If we take a quick look, this is one where it's multiply by 2 and subtract 4. This is add 4, divide by 2, so it's trying to undo the operations. So you'll notice what I've done is I've taken, to compare the values, these values here are the inputs that I'm going to use this time. So let's see what happens. If I put in negative 8, that means I'm going to get negative 8 plus 4, so that's going to be negative 4 divided by 2 is negative 2. And that's the same thing I had before. So I keep going, negative 6 plus 4, that'll be negative 2 divided by 2. That'll be 0, that'll be 1, that'll be 2. Okay. So that's one way we can sort of verify whether this is in fact an inverse, is we can check to see that the points undo each other. So when I said think of a function as like a machine, you give it some input, it gives you an output. In this case, here's my input, here's the output. If you look at it this time, they basically reversed. If you reverse those, you get back to where you started. Okay, so that's what we think of as a reverse for an inverse, that the input becomes output, output becomes input. Does that make any kind of sense at all? Sort of? Yeah, it's early still, I know. Okay, so first off, what do you notice about the points in the table? Let's, I'll put the table back up here. Anybody notice anything? Is it fair to ask that before 9 o'clock in the morning?
Y column
No?
is empty.
Well, the y column's empty. The y values, it's redundant, but the y values are the same as the values here. I'm not sure what my intention was when I put it there in the first place, but well, I think I know why. It's because it would have been to actually write this column as 2 times negative 2 minus 4. But you know, being that you guys are a pretty quick group, I think that would bore you to death, so maybe I skipped that column for you. But yeah, so y is empty. But what do you notice about the x and y's? They're letters, yes. Well, I guess before 9 o'clock in the morning, that's the kind of response I should expect. But the x's and y's are flipped. So if this is the x coordinate and this is the y coordinate, then in the inverse, they get flipped, x and y. So if we're talking about it for points in the table and graphs of a function, it's going to be nice to think about this as x and y coordinates are flipped. So if you're with me so far, I know Connor is because he has a big honking cup of coffee right now. If you're with me, and I told you that I have a function, I'm not going to tell you what the function is, but I'm going to tell you that the function has the point, let's say 0, 5. What can you tell me about the inverse? There'll be the point 50 on the inverse then, backwards, flipping the points. So we're going to take a look at the picture of these two. The first one was 2x. I'll just write them down again. This was y equals 2x minus 4. And then the other graph was y equals x plus 4 over 2, which, to make it easier to graph, this is probably the way we would do the graph of it. So let's take a look at the two pictures and see what we notice here. So to start, 2x minus 4, 1, 2, 3, 4, and let's see here, 2x. So it's going to be a fairly steep graph. Let's see what I can put together here. Oops. And this side here. Okay, and then I'll also put in this one here at 1/2 x plus 2. So at 1/2 x plus 2, there's plus 2, and 1/2 means the slope is going to look something like this. And I'm still learning how to do the Wiimote setup here, but so I'm off a little bit, but roughly that's what those pictures are going to look like. And it's not really obvious to you the first time you see it, but the graphs also share an important relationship. And that relationship, I'm going to need a different color here, so let me just get, yeah, I'm usually not very good at this part of it. Let me just... Okay, so the graphs have this relationship. Again, I don't think you'd see it the first time you look at it, but well, maybe somebody does. Does anybody see any kind of? Sorry?
Where they cross.
Where they cross? Yeah. Again, it's off slightly because of the Wiimote's not quite caught up to the projector. But the important part for this one, I'm going to draw this line here, y equals x, straight through the middle. So, nope. I'm gonna have to do it on the tablet because it's not cooperating today. But the line y equals x, if I draw it, there we go. If I draw that line, then you're not familiar with this term yet, but what we call this is, we call this a reflection, because any point that I take, for example, from here to here, if I go straight across the other side, it's the same distance away. If I go from here to here, it's the same distance, well, kind of. Again, my artistic abilities sort of limit that, but it should be the same distance away on either side. So let me just see here. I can also show it to you a little bit better, so why don't we give this a shot. If I show it to you on some proper software, where's the software? Shoot. Did I show you guys the Graphmatica software? I can't remember. Anyways, I'm not sure. I thought I had it installed on this computer, but I'm going to have to stop it. I don't think it's there. But anyways, as I said, if my artistic abilities were a bit better, then I'd be able to show you it exactly. No, it's not there. So, but that's the idea here, is that the graphs are related by a reflection on the line y equals x. So and again, it's the blue line in this picture.